Hello everyone. Today I'll walk you through an advanced data pipeline setup using Synapse Capsule Designer. This powerful tool automates the entire data processing, anomaly detection, and model selection journey, turning raw data into valuable insights. For this demo, we'll focus on an animal health monitoring use case where we analyze vital health data to detect abnormalities in lab animals. This is crucial in biomedical research to ensure early detection of health issues, reduce mortality rates, and improve experimental accuracy. By the end of this demo, you'll see how SCD seamlessly cleans and normalizes animal health data, detects anomalies in vital signs, selects the best models for predicting health risks, and also generates reports and delivers insights via email. Let's dive in. Setting up the capsule and main flow. To begin, we create a capsule in SCD and define the main flow with a start node and an end node. Before that, let's go ahead and give it a name and description. This flow will accept incoming data via an HTTP listener node. Let's go ahead and add it. Now let's pass it through two parallel processing paths using a data processing subflow, and then merge the insights back into the main flow using a report generator node, and for an email delivery system we use an SMTP node. The two paths in the container are health stability score, and the second path is advanced data analysis with model selection. These paths allow us to process and analyze the data in parallel before finalizing the insights. Now let's add a data cleaning node, a data normalization node. These two handles missing values, removes duplicates, and normalizes the data, and standardizes features like heart rate, weight, temperature, etc. The feature engineering nodes create health metrics such as 3-day moving averages of vitals, activity score derived from behavioral data, risk factor calculations for anomalies. And finally, an anomaly detection node uses statistical methods to flag animals with unusual vitals, indicating potential health issues. And for the second node, similarly, we have a data cleaning and data normalization nodes, a feature engineering node, and again an anomaly detection node for detecting abnormalities. In addition, we'll have a model selection node, which passes the data through various tests for better insights, and this suggests models Now let's go ahead and configure these nodes' properties. As you can see, this filters out the invalid data fields from the data. The data normalization as well. Here we need to select the properties on which we need to perform, and the min-max of weight, temperature, and heart rate. For the feature engineering node as well, we use the expressions to calculate 3-day averages of heart rate, temperature, and weights. And similarly for the anomaly detection, we use the contamination score, remove anomalies, false or true visualizations, and the output directories. And here we calculate the health stability score based on the 3-day average scores of vitals. And similarly in the second path also we define the values. And the model selection, we have a test size, the target variable we are going to perform the tests, that is health stability score, the adjusted R2, and these are for few methods that we have selected. The linear regression, decision tree regressor, random forest, and etc. Now that our paths are complete, we save it. Once the main flow is set up, we also configure the endpoint for our HTTP listener. Let's name it lab_report. Similarly, now we configure the report generator properties. Let's name it animal lab report. And the document type that it's going to generate will be an XLSX for both the paths. Now an SMTP node. Here we configure the email, password, and 2 CC and BC list. Now let's go ahead and save the flow. Once it is saved, I'm going to download it. Now let's head back to the Postman and see what our pipeline does in action. Here, let's configure the endpoint, and it's a post method. And we have a raw data that we collected from the animal lab reports. It has an animal ID, species, weight, heart rate, temperature, and other details. Now let's go ahead and click send. Here we have a 200 OK response, which says that the data processing is completed successfully. By now we must have received an email. Here is the email that I have received. It says what tests it performed and what are the file names that it generated. Below are the attachments. We have an anomaly score distribution for the count and anomaly score, a box plot of health stability score by anomaly flag, and a box plot of heart rate 3-day average by anomaly flag. We also have a lab report that is generated. We can save it to downloads and see what it has. Here you go. This is the results from our Path 1 health stability score. Using our temperature, weight, heart rate, and other details, we have calculated a health stability score. And also, using our anomaly detection node, we have flagged it either 0 or 1. 1 indicates that there's an abnormality in the species. As you can see, we also have anomalous fields like temperature outlier, heart rate outlier, which indicates that the particular aspect is abnormal. Now let's go ahead and check the second path's results. In the model selection path results, we evaluated multiple machine learning models to identify the most accurate one for predicting animal health risks. We tested 3 models: linear regression, decision trees, and random forests. Each model is evaluated using 4 key metrics, such as adjusted R-square, mean squared error MSE, mean absolute error MAE, and the cross-validation score, which confirms model reliability across different datasets. The model with the highest accuracy and lowest error rate is chosen. Example: if linear regression achieves 99% accuracy in predicting health deterioration, it becomes the preferred model for real-time monitoring and risk assessment. This ensures faster, more precise decision-making in animal health tracking. It can be applied across multiple domains like fraud detection, identifying unusual transaction patterns in banking and finance, and in manufacturing, predicting equipment failures using sensor data, and in cybersecurity, identifying abnormal system behaviors indicating potential threats. By leveraging this, businesses can move from reactive decision making to proactive intelligence, saving time, reducing costs, and improving efficiency. This eliminates manual errors, speeds up our decision making, and enhances overall research accuracy. SCD isn't just a tool, it's a game changer for animal health, fraud detection, cybersecurity, and many more use cases.